I'm Roald Page, and I'm about to flip the way you think about the relationship of light and sound on its head. Why is 42 violet blue? 42 is violet blue because 42 Hz is an E, 44 octaves below the frequency of violet blue light. All visible light takes place over the course of less than a single octave worth of frequencies. This starts on the lower end with the red limit at approximately 429 terahertz, which stands for a trillion hertz. It stops on the upper end with the violet limit at approximately 750 terahertz. The red limit at 429 terahertz is a G, minus approximately 8.06 cents, and it occurs in the 44th octave. The violet limit at 750 terahertz is an F, minus about 40.95 cents, and occurring in the 45th octave. An octave is a unit of measure representing a doubling of frequency. Since the distance between the red limit and the violet limit is less than double, that means that all visible light takes place over the course of less than a single octave. Harmony refers to the mathematical pattern generated by the interaction between frequencies. The more simplistic the relationship between interacting frequencies, the more harmonious the resulting wave pattern will be. Since multiplication by factors of 2 is perhaps the simplest of mathematical relationships, octaval harmonics can be considered among the most harmonious. This is why the letter names for the keys in the 12-tone scale repeat every octave. E in one octave is similar enough mathematically to E in another octave to be considered the same note. Since both light and sound travel as waves, their physical harmonic interactions can generate unique waveforms. But between the two, their reactions are limited by the separateness of their mediums. Light's waveform is carried by a photon traveling at light speed. Sound, on the other hand, travels as a cascade of particle movements through a medium of matter, where one particle passes the vibrational energy on to the next. This being said, photons do encounter and interact with other particles, so much so that some of the most common life forms on the planet even consume and utilize the photon's energy to survive and thrive through a process we know as photosynthesis. Photons carrying the light's waveform impart energy to the matter they contact. If that matter is also carrying a sound wave, that sound wave will be minutely changed by the interactions of the photons in the medium. So too will the waveforms of the photons that get reflected or refracted in the medium be changed by the vibrations of the sound waves. Even though our sensory organs that perceive light and sound process these somewhat separately in the brain, the physically unique waveforms generated by these physical interactions of light and sound are still independently experienceable. And harmonies in these interactions can have potentially positive experiential effects, much in the same way that regular sound harmonies do, or in the same way that complementary color combinations do. What this all means is that mathematically significant combinations of sound and color could be utilized to create unique experiential potentials. It also means that harmonic interactions between light and sound could generate states of unique physical properties that could be of great interest to science.